Hey fellow cosmic hobbyists, who wouldn't love a good space adventure with about 800 of your best friends? In this episode of Cosmic Quest Hobbies, we build a large colony transport vessel to do just that. So I'm making an old school colony transport. I'm going to make this, I believe, in 1/350th scale. This is just a basic idea, kind of to give me a starting point. It'll have some ion engines in the back. It'll have a fusion reactor section. And my thought is this is actually about 20 years before the Pathfinder is able to develop warp drive technology. So this is, old school, which for us right now would be new school, but this is old school in my universe. So they'll, at that point, have fusion energy figured out, and it'll have a shuttle bay of some sort there, a small bridge. And I know this looks plain on the top, but there's going to be quite a bit up here. There's going to be probably some kind of, radar dish or redundant dishes. There's going to be some kind of support wings that come down here on the sides. I'm not sure, but just this is very much the starting point, just an idea that's going through my mind. I wanted a solid structure with a couple of mounting points for the interior of the ship, so I decided to use a couple of 1x2 pine board pieces. After I cut the boards to the size I wanted, I glued them together with regular wood glue and clamped them together and set this to the side to cure while I worked on other parts of the build. While my wooden center section was off curing its wood glue, I started to make the round center sections that would become part of the habitation module cylinders. For this, I used some trusty styrene sheet in 40 thousandths thickness for extra rigidity. I drew a set of center lines that would become the center of the circles. And to make the circles, I used a compass set at 3.5 inches, which would make a circle of 7 inches in diameter. At the scale of this ship, that would equal to just a bit over 200 feet in real life. While the pieces were still in the layout phase, I thought this would be a good time to also draw in the inner circles where the large habitation module bearing journals would be located. There's more to come on the large bearing structures in a bit. Once I had these all drawn out, I scored the 4 rectangular sections and snapped them out by hand. That is one of the great things about styrene. You only need to score it, then you can easily snap the pieces out by hand. Once I had those pieces out, I did a rough cutout of the round sections with a pair of scissors as close to the pencil line as possible. I was pleased that I only needed to do some minor sanding of the edge to get them where I wanted them. I also cut out the centers to fit over the wooden core, which with the two 1x2s glued together ends up being 1.5 inches by 1.5 inches. What I wasn't thinking was that the core would be a smidge bigger than that with the styrene laminate that I would be adding to it. So before I got too far, I took a step back and added the styrene strips to the wooden core. To add these strips to the wooden core, I cut 4 of them that were just the right size to fit nicely to the sides. Then I mixed up some 5-minute epoxy to smear on the sides of the wood. Once I had the epoxy on there, I placed one of the styrene strips on it, then pressed it into place. I repeated this process 3 more times to completely cover the sides. I wanted to laminate the styrene onto the wood core so all my round habitation module sections could be solvent welded to it. And I didn't forget to add the small styrene squares to each end either. After the epoxy had cured and the styrene strips were well stuck in place, I set up to drill some holes into the core for creating the 2 mounting locations. I knew I wanted to have one of the mounting spots right in the center for convenient mounting to a base, and a second hole right in the back in case I wanted to be able to do some unique photos or video with it against a green screen background. I marked the center of the piece as well as the center of an end cap and drilled pilot holes. The center mount hole I created with a small Forstner bit and used a regular drill bit for the end hole. Once these holes were created, I epoxied and pounded threaded inserts into them. These are threaded for 5/16 of an inch threaded rod or bolts. Since I wanted to have lights on this model, I needed a way to power them. The lights I chose were some LED lights I used on my first contact alien vessel. These LEDs are powered by 5 volts and can run off USB power. For that reason, I thought it'd be cool to install a USB-C connector on the bottom for the ship so it can run off any USB 5-volt source. I purchased the plugs I used from Amazon. I'll leave a link in the video description below if you'd like to check them out for your own projects. While I was working on the center section bearing support, I decided this would be a good spot to install a power plug. I designed it to go on the bottom so the power cable could be hidden by the base mounting structure. I cut out a spot in a small piece of styrene for the plug to be recessed in and glued it in place with superglue. Once this plug was in place on the habitation module bearing support, I tested it. What a good feeling to see that it works. The design I created for the habitation module will have 2 rounded end caps each, which are made from 40,000 styrene for extra strength. The first section I put in place was the center section, which slid easily onto the center core and glued in place with my favorite Weld-On 3 solvent. To add extra stability to the mount, I also glued some styrene gussets in place. I decided on how far apart I wanted the end caps and placed those onto the center core section, using the same styrene gusset technique for added strength. Once these were all in place, I thought it looked pretty cool as it was, but not too much like a ship yet. There is also a bearing journal in between the center section end caps, as well as bearing journal that will be at the end of each end cap. I figured since there are extremely large rotating habitation modules on the ship, they would need some kind of bearing structure for them to rotate in. In my imaginary universe, CQH Aerospace reached out to the well-known automotive bearing manufacturer Timken to see if they'd be interested in making them. Initially, they thought it might be a bit too large of a project for them, as they are more used to making the wheel bearings for things like a Dodge Grand Caravan. But after a lot of discussion amongst the engineers, they agreed to the project. All they had to do was put some high-quality rollers in there. The actual structure I did use for the ship was my typical styrene in 30 thousandths thickness. Once I had all 6 inside pieces cut, I sandwiched them together into a solid structure. Once they were together, I thought they looked pretty cool. These structures had additions to them where I was initially going to install truss work or something similar, but I changed my mind later. I also realized that once I had the bearing structures put together, I still needed to split the middle one to go around the center journal. I didn't actually give that part any forethought. And in retrospect, I think I way over-engineered the actual construction of this bearing assembly. I definitely could have simplified it more and saved a ton of time. I'm always learning as I go on these projects. With the habitation end caps in place and the bearing structures complete, I moved my attention to a top structure. I built this out of the same styrene and used Weld-On 3 to add the sides and ribs to the center. The center ribs also got a hole in them to run wires through for the lighting. On a colony ship of this size, there would also likely be a lot of storage up here, as well as maybe some zero-G labs or food growing fields that would do well in a no-gravity environment. It would also double as an additional structure to help shield the habitation modules from radiation. And of course, in this model, it doubles as a location to run any extra wires for the lights and power. After the main structure of the top was built, I turned my attention to something that would be very important for the members of this colony ship. With so many ion engines and a fusion reactor lodged in the back, a large radiation shield was built. This was also built from styrene. Once the interior structure was complete, I used superglue to connect it together and then Weld-On along the edges. I ran wires through the inside of the structure for the LEDs that would eventually be inside the engines. And once the wires were run, I glued the structure to the back of the core. I'm not sure what it looks like yet, but it does look high-tech. With the basic structure of the radiation shield complete, I directed my attention to the front of the ship. This section will have a small bridge to control the ship's flight, as well as zero-gravity labs and more storage areas. With a large colony going to another planetary system, there will be a need to have lots of storage aboard this vessel. I built this out of more styrene. I had a basic idea what kind of shape I wanted, but I just really let the ship tell me what it wanted to look like, and believe me, that was kind of a weird conversation. I also ran wires to this section as there would be lights for the bridge as well as the storage and lab areas. One of the things I was concerned about with the lighting on this build was preventing stray light from leaking out from everywhere. A cool idea I found out about was using paper chipboard to make little light boxes out of. This material is thick enough that light won't bleed through it. I determined what size I wanted for each light section and cut my LED light sections to match the size. To help reflect more light where I want it to go, I also lined the inside of the light boxes with a reflective aluminum foil tape. I ordered this tape on Amazon, but you can get it from any home store. It is used to cover the seams in a home's HVAC ductwork. I created light boxes for the gaps between each habitation module, the bridge, and 2 other sections on the front of the ship. As I touched on earlier, I used the strip LEDs that are powered by 5 volts. I cut all the strips the size I wanted and soldered wire leads to each one for easier hookup to power. I also knew I wanted to light up the engines. I designed these ion engines in Tinkercad, mostly from scratch, as well as doing some digital kit bashing from other files I found on Tinkercad. I knew that if CQH Aerospace was designing these engines, they would create a custom name for them, kind of like SpaceX calling their custom rocket engine the Raptor. CQH decided to name these engines the Hermes class of engines. This large colony vessel transport will utilize 6 of them, which will make this the most of this type of engine ever placed onto a space vessel. Usually a cargo or transport vessel would only have 2 or 3 at the most. But then again, this is a massive vessel that will require many engines. I was doing some research on what gas the ion engines use to ionize, and the information I found was that xenon is the most common gas. With 6 large engines, I figured a pretty large supply of xenon would be necessary. I designed a xenon tank in Tinkercad and created this setup of 8 tanks. In 1 3/50th scale, each of these tanks would be equivalent to 30,000 gallons. With 8 on each side, this is a total of 32 tanks, which would also offer some redundancy. With the main lights in place, I decided it was time to start skinning the rest of the habitation modules. I used more styrene square rods and strips to bridge the sections between the modules, then added some large triangles for bracing. I did the same technique multiple times to frame in the lower section of the habitation modules. After all of that, I added the larger panel sections. This was basically the same process as adding the styrene to the top sections. I used superglue for the center spans that would be hard to almost impossible to reach with a weld on, and I used that same weld on for the edges. Once the styrene sheets were in place on the module, I could actually start imagining the complete structure of the ship. While I share some of the overall build footage from the ship's construction, I wanted to say thank you to my paid Patreon members. Your help in keeping this cosmic hobbyist stocked with building materials and supplies is greatly appreciated. Your support really means a lot to me. And I also thought I would share the background story behind this vessel construction. Approximately 10 years before the construction of the Pathfinder vessel, a large conglomeration of what CQH Aerospace was part of decided to design and start construction on a colony transport ship. The goal of this vessel was to bring a large number of passengers to Proxima Centauri to explore the possibility of living on a planet or on another star system. This vessel was designed and construction started before the anti-gravity and warp drive technology was created and implemented for vessels like the Pathfinder. What's crazy though is that this colony ship was actually completed right about the same time that the Pathfinder began construction. By that time, there were a large number of people that were prepared to live out the rest of their lives aboard this vessel and had their hearts set on doing just that. Unfortunately, there was no way to implement new warp technology in the almost completed colony ship. It was just too immense for the first generation of warp drives to propel, not to mention the difficulty of retrofitting it into the already completed construction. There was a lot of discussion about whether the colony ship should even still go on the trip, but it was decided the knowledge gained from such a long voyage would be extremely beneficial, and there could always be supply runs and stops by the passing warp-capable vessels if needed. And what can you say? I guess the joy is in the voyage, and not in reaching your destination. I also thought I'd share how I got the name of the ship. It will be called the USS Greebly. It is named after an astronomy teacher I had in middle school, and after my dad's love of space with the Apollo programs and other related things, Mr. Greebly was a huge inspiration on my love for outer space and astronomy. I asked if he would like a ship named after him, and he did. But he wanted a ship that was based on currently possible technologies, so I created this one and made sure I could fit the background of it into my overall storyline. While this ship will have a large array of antennas on the starboard side, these are mainly for use by the onboard navigation systems. But for long-range communications back to Earth, there is a redundant system of communication dishes that I created in Tinkercad and 3D printed. These dishes are protected by a garage-type structure where they can slide out along the tracks to send and receive messages from Earth and go back into the protective bunker when not used. Of course, the further away they get from Earth, the longer it will take for the messages to go back and forth. But I figured the crew still needed a way to send and receive messages if needed. As I mentioned earlier, I was originally going to install some kind of truss work along the sides of the ship as a type of reinforcement for the vessel. But as I was working on them, I decided they were too fragile to make appropriately. I needed to decide what to do with the outrigger sides that were just hanging down. As I was thinking on that question, I decided that the rotating section would probably create some kind of vibrations that would need to be compensated for. This led me to creating a set of massive shock absorbers that would connect to the bearing structures on each side of the ship. I also designed these in Tinkercad and printed them on my 3D printer. While I did install a cargo shuttle bay door on the starboard side below the bridge section, I figured this ship would need more than one spot where a shuttle can land, so I added a shuttle landing pad to the top of the structure. To get the custom shape just like I wanted, I used my new Silhouette Cameo 4 cutter. Using this cutter, I was able to design and score the shape into 20 thousandths thick styrene. It made a beautiful round shape that only needed some minor cleanup of the edge. Before I got too far with the detailed skinning of the ship, we had to add our little heart in place. I picked just the spot that it should go, and my wife put it in place with super glue. This was a real team effort. And once again, my new Silhouette cutter came in super handy for making custom paneling to skin the ship with as well. I wanted to add a bunch of depth to the skin structure, and I decided to try creating a custom panel design that I could score into sheets of the same 20,000 styrene and apply like a thin laminate to the outside, with my hopes that my final wash would highlight the lines and add a sense of scale to the ship. Overall, it worked out okay, but still needs some tweaking to really show up well on future projects. And after I got the ship skin laminated with a DIY textured paneling, I turned my attention to adding all the little detail bits. These really do a good job with adding overall interest and depth to the structure. These were also made from 20,000 styrene, and some even thinner styrene I got from cheap plastic plates from the dollar store. Once I had all the little styrene bits on the ship how I wanted them, I taped off all the spots I didn't want to get any primer on. Then I took it down to our garage so I could prime it with a garage door open for ventilation. After priming the ship off camera with Tamiya fine surface primer, I 3D printed some inner diffusion trim rings for the ion engines. These trim rings will get a layer of frosted plastic to diffuse the LED light, as well as a layer of ribbon material that looks high-tech or like it could be an emitter system. With the trim rings complete, I moved my attention to actually painting the engines. For the color on these, I used airbrush Vallejo jet exhaust. I really liked the metallic brownish color that it gives them. And while I was at it, I also painted a large radiation shield structure that I 3D printed from a file I created in Tinkercad. I definitely made some good use of my 3D printer for this model. When I decided on the scale of this big beast, I thought it'd be a bit easier to create some of the pieces and parts I was wanting to make, but with everything having to be so small to match the scale, it ended up being a bit more difficult than I expected. One of the things I needed to make was the window inserts to make it look like there were a bunch of little windows on here. I also designed these in Tinkercad from scratch, using the measurements of the various spots on the ship. Once they were printed and cured, I placed some of the aluminum foil tape on the back to help prevent any extra light from bleeding through them. With these inserts all foiled up, I placed them to the side until I was ready to permanently glue them in place. I was finally able to do some detail painting of small bits, pieces, tanks, and piping. I painted the xenon tanks a green color to match what I researched to be the proper industrial color for that type of gas. I could definitely be wrong on the color, but then again, I haven't seen any actual colony ships flying through space yet, so either way, who's to say, I guess. I also painted the small panel bits a darker gray to add more depth once it was all complete. I also mainly stayed with painting the larger pipes on the engines, as the others were just too small to do anything with. I decided to rely more on the final wash to get into the nooks and crannies of those pipes to add depth and separation. You also might see a brighter light on the surface as I'm painting. While the lights I'm using are pretty good, I still wore a headlamp for some of this painting as there were some dark areas that the light didn't get to and made it hard to see as I was painting them. One of the big reasons I wanted to get the silhouette cutter was to make custom paint masks. I used it to make a mask for each pod, and I thought it would be important for these pods to be labeled, since if there was any reason for repairs to be formed on the outside of the habitation modules, it might be confusing which module needed to be worked on if they weren't labeled. I painted the color on with my airbrush and a few fine coats to minimize the risk of the paint bleeding under the mask. And before painting the black text in place, I made sure the white paint was dry with my trusty hairdryer. I also cut a custom paint mask for the landing pad marking lines. I'm pretty impressed with how fine of a cutout it can make. It's getting pretty close to done. After I installed the window inserts, I applied a coat of Vallejo Mecha gloss varnish. And once this cured, I mixed up some darker gray oil paint in a small cup and added odor-free mineral spirits to thin it and allowed it to be placed around the ship to bring out the textures and the weathered look. My wife even got in on the weathering wash. After all the mineral spirits evaporated, I used cotton swabs and paper towel dipped in that mineral spirits to take the extra wash from the surface, which left the color in the crevices right where I wanted it to be. And after all the extra wash was cleaned off, I created the nameplate for the base and glued on a little mini shuttlecraft on the landing pad. After all this was complete, I sprayed a generous coat of Vallejo Mecha matte clear finish on everything. Once this coat cured, I called this build done. Thank you for coming along on this build of the Colony Transport Vessel. If you enjoyed this and would like to see my other videos as they come out, hit the like and subscribe button and notification bell to be alerted when new videos are released.